Hello and welcome to our discussion for today. And the objective of our discussion is to talk about the mechanisms that influence the growth or influence an increase in the cell population, or what are the factors that cause the opposite, which is a decrease in the cell population. So if we have a cell population or a tissue, that cell population is susceptible to factors that cause it to decrease in number. There's a decrease in tissue cell population, and there are also factors that cause an increase in the tissue population. So what are these factors? Okay, so if we have a cell population, that makes for us a tissue. So what do you think the factors that cause an increase in that tissue population? First of all, the first factor will be differentiation. Differentiation is a process by which cells mature and differentiate from a primordial form that is a neutral form into a form that has the capacity to perform structural and functional properties. So these cells, they differentiate into a more mature and into a more structurally and functionally active form. So that is one form that increases for us the cell population, that increases the number of cells in the tissues, is when the cell receives growth factors that stimulate the cell to differentiate into mature cells and more functionally and more structurally useful cells in the body. Another factor that increases for us the number of cells in the population would be proliferation. And proliferation is when cells maintain their structural and functional apparatus, but they increase in number. So in differentiation, you had a primordial cell that differentiated into a more mature, a more powerful, a more structurally efficient, and a more functionally active cell. But here in proliferation, we have cells that just increase in number, but they are from the same nature and in the same form. And we see proliferation, for example, in healing. So these cells that are participating in proliferation in healing, we had a group of cells, for example, in the cell population that were susceptible to superficial injury, and these cells were scraped out. So cells that are surrounding the cells that were scraped out, obviously after the processes of inflammation where macrophages would come and remove all the necrotic debris and all the remaining cells, then cells that are around the tissue, cells that are around these cells that were damaged, they will start to proliferate to make up for these lost cells. Another factor would be cells that proliferate, but they are not very adjacent to the cells that are damaged. In fact, you have cells that start to proliferate from very far away, and we see this in wound healing, and particularly wounds that are so deep that go into the underlying tissue. And what we see here is that if the wound is so large, you will see that the ends of the wound will start to proliferate and cover a sufficient amount, but the center of that wound will only be filled with fibrosis, with fibers. So we will not have proliferation in the middle. So that just shows you the capacity of proliferation in a localized position versus the capacity for proliferation from a very distant site. So proliferation could happen from a near site or from actually a far site. So that's the second way or second mechanism by which cell populations can increase. They can increase by differentiation, they can increase by proliferation, and also another way the cells can increase in their number and in their mass would be by tissue stem cells. There are resident tissue stem cells. These stem cells are known as adult stem cells. So these are a more differentiated stem cells. They are not like the embryonic stem cells. They are not like these totipotent stem cells. Totipotent stem cells are stem cells that have the capacity and potential to differentiate into a multitude of different cells. We can have a totipotent stem cell that could give rise to pancreatic cells or cardiac myocytes or liver cells, or any different type of cell can arise from a totipotent cell. However, these more differentiated pluripotent stem cells, also known as the adult stem cells, they have a limited capacity. They have already been restricted into being able to proliferate and into differentiating into a specific pool of cells. So assuming a tissue was injured, those resident adult stem cells, these resident pluripotent stem cells, they can supply a source of cells. They can themselves mature and differentiate and proliferate and give us more cell population. So that's the third way, stem cells intervening and engaging in the process of making up for cells. What else do we have? We have then we talk about mechanisms that decrease the cell population, and obviously that would be cell death. When cells die, whether by apoptosis due to, for example, internal defects such as DNA damage or misfolded proteins, or there is a lack of nutrients that causes a short of supply into the making of structural and functional proteins that the cell needs, and then the cell may be suffering from cell aging, or some problem causes the cell to elicit apoptotic cell death, or maybe there are external factors, external stressors that damage the cells, but the damage is not so severe for the cell to die by necrosis, but the cell realizes that it has been damaged beyond salvage, and now the mitochondria is aware and awake, and the mitochondria will start to trigger the apoptotic pathway, and then these cells will die. So now we have lost cells through apoptosis, and then, as I said earlier, we have loss of cells by necrosis. And when we have loss of cells by necrosis, the removal of these cells will be by the microbicidal effects of the macrophages in the classical pathway. So classically, the macrophages would arrive to the site of these damaged cells and remove all the necrotic debris and gallop and swallow and engulf all of that necrotic debris and engulf all of these microbes, whether bacteria, viruses, fungi, or parasites. They would engulf them, and then after everything has been removed and we have a clear environment for cell growth, then the macrophages themselves would now follow an alternative pathway known as the alternative pathway, known as the M2 pathway, and that pathway is actually the healing pathway, where macrophages, if the damage is so severe that extends to the underlying tissue, the macrophages would elicit healing by fibrosis on the recruitment of these fibroblasts that secrete TGF beta, and then we will have healing by fibrosis. But if the macrophages realize that the injury is not so deep and rather superficial and localized and very well countered, what happens is the macrophages would elicit healing by proliferation. So now let's just look at the diagram. This here in yellow we have our baseline cell population, and we said that I put in positive, meaning in positive sign, meaning there's an increase in the number of cells. So these cells here in yellow, these are known as the baseline cell population. We have a known number of cells that comprise for us the baseline cell population. Now, what are the factors that lead for that baseline cell population to increase in number? First of all, we have self-renewal, where these cells can renew themselves. Like I said, through apoptosis, when cells that are old and not serving their structural and functional properties, then they are lost by apoptosis, or maybe these cells are lost by necrosis. So these cells that are really close by to where these dying or these dead cells have been dead, then these cells can self-renew and proliferate to make up for that loss. So that's one positive pathway. Another positive pathway, we have the proliferation. So you have that restricted and that known number of cells in a population. That cell in a population would increase in number through proliferation, and that's how we get more cells that's how we increase our baseline cell population, provided we have the growth signals that push and stimulate the baseline cell population to proliferate into more number of cells. Then another form through which the baseline cell population could increase, and another mechanism through which the baseline cell population would increase is differentiation. We have a new form of cells that are structurally and functionally different from these baseline cell population, but they still arise. And now we have a new baseline cell population that is more differentiated and is serving more growth and development demands. And then we have another source through which we can increase the number of baseline cell population, and that would be the stem cells. And to be more specific, that would be adult stem cells, which are stem cells that are localized nearby in the tissue, and they can contribute to the making up of cells that have died or lost or damaged in inflammation, and they can provide for us a pool of cell population. So that is another way through which we can increase. See the positive sign? We can increase the number of baseline cell populations. And then we have in the negative sign, we have what are the factors that deplete or cause loss of baseline cell population. That would be cell death, whether you see the number decreased from the actual number of the baseline cell population, and you see that the cell death could be either by necrosis or by apoptosis, and cell death could be is actually caused by irreversible cell injury, and that irreversible cell injury is attributed to either internal stress factors, such as we mentioned defects in the mitochondria, or maybe loss of nutrients, or hypoxia, or maybe misfolded proteins, or internal damage or lack of very crucial important enzymes, and their absence causes a structural or functional defect. Then the cells would trigger apoptosis, or maybe the cells have died by necrosis due to external causes of stress, meaning a high increase in temperature or low increase in temperature. These are physical causes of stress. We have chemical causes of stress and damage, such as these corrosive chemical agents. We also have these microbes that come from outside, such as the viruses and the bacteria, And we have bacteria that use opportunistic infection, so from inside they can cause damage inside of the body. We have parasites, we have viruses, we have also fungi. We have these different kinds of microbes that cause the cells to damage the cells, and the damage could be so irreversible that the cell must commit to cell death or can just abruptly die by cell necrosis. Well, this is just a very simple topic to begin our discussion, and that is to just have an understanding of what are all the possibilities, what are all the possible mechanisms by which the cell can increase in number. We have ways the cells can increase in number while being in the same form, and that is through cell renewal, and that's through proliferation. And we have also another way by which the cell can differentiate into a more structurally and functionally distinct set of cells that give our tissue the proper cells that are sufficient for its structural and functional needs. And then we talked about how stem cells are also a source of providing cells for the population. And last but not least, we have factors that cause a depletion, as shown by the minus sign. That shows us a cell death due to apoptosis or necrosis. Okay, and we talked about the different types of stem cells. We have pluripotent stem cells. They are adult stem cells. They are not embryonic stem cells. These adult stem cells, they can differentiate and they can proliferate, but they can only give us so much. They cannot give us so much. They give us just an exclusive and a restricted potential for these for tissues. But however, totipotent stem cells, these are like the zygote, these embryonic stem cells, they have a multitude, they have very high potential to differentiate into very different cells of different origins, like pancreatic cells or liver cells or cardiac myocytes. So thank you very much, and we'll see you in the next video.